First of all, thanks for bearing with me on this. I know it's not what you like. It's not what you came here for. But I promise, I'm trying to make you a better person. No, I mean, I don't mean. Sorry, when I was I nearly dropped out of high school, and actually I dropped out of high school because it was math. I screwed up math. Actually, I screwed up English and math. I screwed it all up. Didn't have much time for school. I was real busy, and I was in a PE class one of the days I did go, and I was running. I was like, running, it's a lot of work. And so me and my friends kind of took a shortcut and hid somewhere, and the football coach found us. We were terrified. He's like, look, your PE coach is trying to make you better people. And it's stuck with me, right? So that's what I'm trying to do here. We're trying to make, but and there may be many of you who would rather be running right now than doing this, but let's try. No. You have one of those 0.0 on the back of my car? No, just kidding. So once again, R works with packages, and many of the packages you have to download from somewhere. In fact, most of them. And most of them work in this install packages arena. There is a place where you can go over here and find them, I think, if they're installed on your computer themselves. But I try to do everything in syntax. We just downloaded the dev tools package. Did you execute that? Did you get that to run and install? And then you type library dev tools. It should not see. You should not see anything, right? You run that line of code. There's nothing. That's a good sign. That means it loaded without incident. So you successfully downloaded your first package and loaded it. Hooray! Yes. It should be the same. I may have typed. What line does the?
There was an extra line in the code that you erased right when you opened it up, and so that.
Is it 90? Are you at 90 for this? Yeah. Does that work? 91? 90. Does that work? Does that match? I'm sorry. 90. Sorry to delete. I'll try not to delete things anymore. I'm just really. I do so much of this coding. I don't know if you do coding all the time. You start to format all the time. It's like, oh, it's really annoying. I'll try not to. I'll try not to format as I'm sitting here. My nervous tics. So we loaded the DevTools package because there's a function I want to use called install GitHub. Ever heard of GitHub before? GitHub. No. What's this? Sounds like a good one. Yeah, GitHub. That's good. I like it. So there's this repository for code called GitHub. GitHub is pretty awesome because you can share all of your code on there, or people can share all the open source stuff you want. So you can find all sorts of things. For me, I'm using it for this class to avoid having the process of the people at CRAN vetting our code, because it just takes time. So I'm going to create things. I'll push it to GitHub, and then every once in a while I'll tell you to go reinstall stuff, and it'll download it and check it and whatnot. But to download things directly from GitHub to run in R, you don't have to do anything other than just use this function called install GitHub. Install_GitHub comes from the DevTools package. And to run that, in the quotes, this right here will never change. The package I created is something called EPSY 905R, all in caps. But this part in quotes here, Jonathan Templin is my GitHub username. And then the slash to it is the path to that package. If you hit enter or hit run, command enter on that line, you'll see it downloading from GitHub and doing the same process of installing. Right now, the package is very light. It has a few data sets in I use for examples in class, meaning you don't have to read them in from files. You don't have to worry about where the files are on your computer or whatever. You just have to load the package and then call the data set, and sure enough, it's there. I also will have a few functions in there, and I'll probably put more functions in as we go through. So I will tell you, though, when I make modification, and it will let you update it. Sound good? Cool. So now, have you been able to? Yes, Ron.
So once that's downloaded, we can go under packages, and we should see it there.
It should be there, yes. I may be wrong. Oh, there it is. Functions, files, and dependencies for Jonathan Templin's EPSY 905 course. There we go. So now we've downloaded it. We need to load it. So we hit the library. We run the library code, library EPSY 905R. Reloads the functions, and you see nothing. Question? Oh, I'm sorry, gotcha. Thank you. Thank you, Jihan. Yes?
Is there like a back feature if you make an error when you're typing, or not really?
No, you pretty much, if you want to delete anything from the console, like if you have this right here, if you have a long line, if you hit Command or Control Delete, and you're on a Mac, Command and Delete will delete the entire line. So it gets you to start over, but otherwise it's just a backspace. If you make a mistake in what you've named an object, you can just go back, correct it, and then rerun it. That's usually what happens. Yes.
Install and load.
Install grabs it from the internet and makes sure it's ready to be loaded. Load makes it so that you can use it in R. So think of it this way. If you download an app, like if you're on, that's the install version. And then load is when you press the app and it runs. Does that make sense? Other thoughts or questions? Yeah. If this gives you an impression of class and you're scared, I'm sorry. I'll do the best I can to get better at teaching R. But this is why we have this type of interactive forum. And in the weeks to come, it'll be more, here's my example file, work your way through it, and you're trying to see, replicate the numbers that you see and so forth. And then I'll work my way through it after you've already done it. But we'll get more of this. You'll get more practice, I hope. So, okay, so now we've read in our data. We've loaded it. We haven't done anything with data yet. Who wants data? All right. The first type of data we're going to import is something called a comma-separated values file, a CSV file. You're probably familiar with those if you've used Excel. R has a built-in function. Any of the functions in R that exist without having to load a package is something called base R, kind of just native R commands and code itself. So there's a base command or function called read.csv. And I'm going to create an object named heights data. And in that read.csv function, I need to tell it what the path to the file is. More on that in just a moment. And I'm going to give it this option, or this argument called strings as factors equals false. And that's because by default, when R reads in your data file, if it thinks you have any variables that have characters in them, in that variable, it will convert the type of variable not to character, not to numeric, but to a type that's called a factor. And factors are actually pretty cool in R. They allow you to do things like ANOVA very easily with lots of groups. But they aren't really cool because if you think it's a character, but it's really a factor, then it stops the things you can do with it. So I'd like to just turn off factors until we absolutely need them. So that's why I put that in there. So strings as factors equals false. So let's go back to the path. Heights.csv. If we go in our files folder, you'll see here, because we can see the file heights.csv here, we're in the right directory. All we need to tell it is the name of the file in that directory, and it searches that directory itself. If you can't see heights.csv, you're going to have to find the path to it on your computer and put it in. And I'll show you that in just a moment. Yes, Sarah, go ahead. Okay, I'll be right there. So I'm going to run it real quick, but let's imagine, so we have heights in, but let me just walk you through it. In R itself, to figure out which directory your R is in currently, type the command getwd, G-E-T-W-D, and then open and close parentheses. What this does is it gives us the path to where R is currently operating on your system. So right now, this is the folder where I downloaded my example from R, and I opened up the file. Yours may be different. Yours will certainly be different because your username is not Jonathan Templin, although if any of you has that username, that'd be pretty cool. A little bit weird, but you know, flattered. The dir function, dir, the old Windows function dir, open and close parentheses, whoops, will tell you the contents of that directory. So here, this tells you the files in there. So if you, like I did, just put the word heights.csv, but you don't see it in this dir function output, it's going to have an error for you. It's going to say, wait a minute, that file's not here. I don't know where it is, right? So you have to go and figure out where it is on your computer. What's that? Oh, I'll show you. Here, let me show you an error real quick. Let's imagine my directory was now user/jtemplin. This is the root of my computer, and I try to write heights in. This is the error I get. Cannot open the connection. That's an odd one. We didn't have a connection here. No, there's no file. That's at least what it tells you. There's no file that can be found. So what we end up having to do is figure out where it is on our computer. So this is where it's a little bit harder. Wherever you downloaded the zip folder and unzipped it, you have to navigate to somehow on your computer. If you're using a Mac, in Finder you can drill into it. If you're using Windows, it's Windows Explorer, I think. The file itself, the path for it, you can find in a Mac if you double-click on the file name and you hold down the Option key. There's a copy heights.csv as path name feature. If you copy that and go back into R, you can, in quotes, paste in the path to where it is. Yeah.
There's a different way. If you use the file.choose function in R,
even better. How does that?
It's just an empty argument.
There we go. File.choose. Thank you.
And then you click it, it'll show the file name.
That's awesome. All right. So file.choose, drill in and find heights.csv, and there it is your file's name. Thank you. I had no idea. That's awesome. Yeah, that's wrong. Here, what I would do, it looks like the output of file.choose is just a character string. So yeah, you could type it in any line. But what I probably would do is just put it up here on line 108. If you type file.choose right here.
I just use it in a separate line.
A separate line altogether. Now, if you put it here, yeah, separate line might be better because it changes the path for you. But if you put it in the function itself, when you go and find file itself, it'll read it into the data frame. So, all right, who wants to see file.choose some more? All right, thank you. What's your name again? Kevin. Thank you, Kevin. Let's do it this way. If I have file path, I'm going to create a new variable. This is going to be on line 109, a new variable named file path, and it's going to be equal to file.choose. Okay? Like that. Can you type that in? File path equals file.choose. When you run that section of code, what's going to do is it's going to pop up that dialog box to find the file. You go and locate your file on your computer, and you click Open. And now, if you followed that, you'll note over in my environment, I have an object named file path. That file path itself is the path to the file. So that's what you need to give to the function to open that file directly. Should I do that again? Okay. I named the file path. You can name the object anything you want. Equals. And I put the word file.choose, all in lowercase. And at the end of that, I had open and close parenthesis. So when it runs this, it's going to run this file.choose function. So if we hit the run button, or hit Command Enter, or Control Enter, up will pop the dialog box. Can you find the file where you downloaded? Where did you download the zip folder to? If you find it, it just went to my downloads folder, but it's going to be different on each of your machines. Where you downloaded it and unzipped it, you can find it. Find it, everybody? The name of the file is heights.csv.
It opens the whole folder.
It does open the whole folder, yep. And once you double click or click that file to open it, it sends the path of it over to this file path variable so that you can see it here in your computer. And then an easy way to make sure this is replicable is to copy that path and just put it in under the file section itself. Whoa. Yes?
So what should we do if the path shows up in our environment but not in our console?
If it's in the environment, so that's what happens if you have it here. If you want to see what the path is, type the name of the variable the name of the object you gave it. So for me, it's file path. In the console, and just hit enter, and you should be able, or hit return, pardon me, and you should be able to see, there it is, right? Yeah, so actually that brings up thank you, Maggie, it brings up a bigger question. Anything you see in the environment here, if you type the name that you see for the object in the console, it'll display what its contents happens to be. So are you with me? Do you have this R file open? Because it's in the same folder as the R file that you have open. Yes. Oh.
I was just saying mine says file choice cancel.
If you hit the cancel button, I bet it says that.
Oh.
There it goes. Yeah. So if you have the file choice open.
Oh, should we open?
Yeah. Sorry. Yeah. Find the CSV and hit open. And make that work. Yes. No, you can name it anything you like. That's right. Exactly. Like that. There are some rules for what you can and can't name a variable in R. Like you can't start it with a number. But beyond that, it's pretty flexible, I think. Other questions? Who needs some help with this? Do this again. Who wants me to do this again? When it's in the console, take what you see from quote to quote and copy it. So highlight it, copy it, and paste it in where you see the file above. Right here. File equals, and the argument of the function read.csv. Okay, I'll walk through it one more time. Ready, everybody? Okay. So file.choose is a function that lets you search your computer for this heights.csv file. Right? It was in the zip folder that you downloaded. And so if you didn't delete the other contents of it, it should be on your disk somewhere. Wherever this make friends with R file exists, it should be on your computer as well. When you run this function, all it does is pop up a dialog box to help you find the file. You find that file, you click open. It doesn't open the file itself. What it does is returns the path of the file as a character. Right? So once again, hitting enter on it here, or return on it here, we go to downloads. This is my system, right? This is the folder I'm currently in R. Have you gotten this far? Okay. Now, on your computer, you're going to have to find where you downloaded the file to. If you can't find it, you can re-download the zip folder and redo it. That's fine. Here, I typically, you put it on your desktop, put it on your downloads folder, somewhere where you can make it easily accessible. Find the file. Here, it's heights.csv. Either double-click it or open it, or hit open. And again, what happens in the console is that you see nothing. But over in an environment, there is now a value named what I called file path, and you can see there's a quote string there, and if I wanted to see exactly what it was, I type file path in my console. How are we doing? Better this time? No. Any questions I can help answer while we're here?
If you type file path in the console,
You should see a quoted string of this long path to your file. Got it? Fantastic. Okay, now once you see the string, go down to the console with your cursor and highlight that from quote to quote. That whole thing. Copy it. And go back up to the read.csv function. And put that in where the file argument is. So highlight, before what I had in this read.csv function was just heights.csv, look like this. You want to erase that, what you saw before, because it's not opening the file. And you want to paste in the whole path, that whole string. And then you can run this read.csv function. Did that work? If you see no red, you're in good spot. How many people are having issues still? Okay, we'll work with you when we get back, or you can re-download the file and try to find it where it goes. So basically, when you get the data in to your environment now, you can see the data frame by clicking it over here. This, as you note in the environment itself, by the way, everybody, if you're not able to completely follow along with this, don't worry. Right? You will be able to get there. And since this is being recorded, you can come back to this spot in class online and repeat what we're about to do. So we'll be able to get there, okay? Yes?
How do you get that on the screen there on top?
This make friends with R file?
How did you get the data?
Oh, how do I get the data up here? That's what I'm going to mention right now. If you go over to the environment and click it, click the data. So you have my mouse finger here. Click the data. It'll pop up over here. Do you have that? Do you have the data in your environment? So it's not read into your machine. If you don't see a file name or don't see a data file named Heights Data, you're not getting the data in somehow. We'll see if we can get some help here. Anybody else? We'll have Jihong will be with you. If you need help getting the data in, Jihong will circle around. I'm going to continue with this class. Again, come back to this at this point in the video online, and you will see it. So once again, you click Data, and up pops the data file itself. You can see all the heights, the ID number. There's 2 variables in it. And you'll note under the environment, on my screen, this object appears in a section called Data, not in the section called Values. And that's because the type of data, the type of object this is, I'm going to skip ahead here. That, by the way, all this right here is about finding your file and doing whatever. If I type the word class and I put heights data, it will tell me it's a data frame. The data frame is very much like the data sets you're used to working with in SAS, SPSS, SATA, and so forth. The data frame is rectangular. It has observations down the rows. It has variables across the columns. The variables can be any type, right? So you can have one column of numeric variables. You could have one column of character variable. So, for instance, if you collected someone's height in inches, you can put the numbers in. And if you collected their sex, male or female, M or F, it can be in there as a quote character. It could also be what we call a logical variable. It could be true, false. All of it can be there itself. So data frames are great because they're a regular way of looking at data. There's, again, columns, observations in columns, variables in rows. And if you want to look at the data itself, again, you can click it over in the environment. You can also type if you type the name of the object, heights data, and you hit a $, it will show you in the console which variables exist. Right? So what's happening here is in R, the object name is the beginning, and embedded in the object may be variables of some sort. To get to those variables, you type the $, and this is why RStudio helps a lot. It helps you figure out what variables exist in your data frame. We have two. We have an ID variable and a heights column. So heights data $ID, this is from my syntax, will show you all the observations of ID from our data frame. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for those of you who have the data in, how's it going? Those of you who are working on it, help is on the way. All right, we're going to do one more data file reading in. How many of you use SPSS? Oh my goodness.
Hey, now,
No.
it's easy.
It's true, it is. You don't have, how do you get your data in SPSS? Import it. We're going to do the same thing here. It's one line of code. Library, actually it's like 2 lines of code, pardon me. Library foreign. So R has with it a package called, a library called foreign, which mainly means the file types that other people use. Stata, Excel I think is in there. I don't know if Excel is. SPSS. If you load the library foreign line, it gives you access to a function named read.spss. And guess what read.spss does? Hooray! Truth in live advertising. Now again, read.spss needs to know the path of where your file is. Because I'm not in the directory that this wide.sav is, if you look at my, actually I am in this directory. Or am I? No, I'm not. I have to go find it. Just like you're doing right now. Or I can go and set my directory again to where it needs to be to make this work. But again, read.spss is what we need as a function. You tell it the path of the file. And now what we want to do, because, all right, it may be a little less easy than SPSS, I have to admit. But to data frame, we have to tell it we want this to save this as a data frame, otherwise it returns an object that's just stupid. So there we go. I don't believe it's, I can call objects stupid, right? I can do that? It's kind of a bad choice. So now I have this wide data file here. So if you're struggling over this step, you might be struggling in the same step you were with the read.csv. You have to find the path to the file on your system. Right? Or you have to make sure that the R terminal, the R environment, its current directory is in the path that you're in. Yes? If the backslash, I don't know what the issue was on your system. It may be a system thing. I don't know. Sorry. Yes? Zipping. Unzipping. It's not coming off the zip folder. I don't know how to fix that. I'll have to find a way to help you with that. Are you using the Windows zip? Embedded zip? Mm-hmm.
It's just showing a zip file here instead of the actual file.
Oh,
I get it.
Yes. The wide, yes. I know that feeling. But if the final step is no longer the CSV file, it's the .svg. Thank you. Once we combine this, so the same. We got the SPSS and then just file.choose to open with the file. Yeah, I did. Not necessarily, not necessarily, it's like something in the file. So you change heights.csv to wide.savg. All right. Yes, Alan. Yeah. For those of you on Windows machines, how does file.choose do it? Yeah, those of you in Windows machines, if you're typing the actual, thank you, the actual file path, the Windows file path is backwards. The slash is I don't know if it's is that a backslash instead of a forward slash? I can't remember which one it is. It's, yes, Ahmed. If you use what? Session, there we go. Yeah, you can choose the directory. That's a good way of doing it too. You can always do that. Anyway, there's lots of ways of doing this. The issue is not, let me back up. If you're having a problem with this, the main thing is to note the file path of your system. If you're not used to file paths, that's a bigger thing. It's kind of an operating system thing. So when you're using your computer, you have to figure out how to get it to tell you where your files are located in text rather than visually clicking and pushing your way through.
Should this pop up under files or under data? I mean, under values.
When you do the read.SPSS, is that what we're talking?
Yes, the wide.
Yeah, it should be under data. But if it's not, that may not be the end of the world. If you type it down here in the console and see what you get. All right, next. If you're still having a problem with this, hang in there. I have to get through some of this today. This is one of the problems with getting to learn R here, but you can still continue to work on this and make this work for you as you go on. The bigger thing is try to learn for your system how to get a file path out of your system, how to translate a file from where it goes. For the Mac, it's fairly easy. If you're used to Finder, you can drill into your system and find a file, right-click, hit the option button, and there's a copy as path name feature. Right? That'll copy the characters for you. For Windows, it's a little bit different. But once you have the path, that goes after file equals in each of these. Right? So it's file equals, and it's the path to that file that opens it up. you have to bring down the right-click menu
Yeah.
and hold the Option button down. And the Copy button changes to copy as path name. Yeah. So the point is, what I'm trying to say with this is, the computer world has made it easy on us to not have to worry about path names, but in the programming world, we always have to worry about them. And so, our being part of the programming world, we can't just easily go and tell it where the file is as easily. Now, but we're going to get there. With you do this, you get it right a couple times, and you do it right for the rest of the time you use it. So hang in there. But let me go through a couple more steps with you with this, and we'll get started here. You'll note the heights data has an ID number 1 through 10, and the wide data has an ID number 1 through 10. And sure enough, these are two different data files of the same people. At least that's what it's intended to be. And so what you may want to do with some data, if you have data in one file and data in another, one common feature that you have to do is to merge them together. Right? So to merge them, there is a merge function. So we can go down and create a brand new data object, all data, and we can give it the arguments, x being the first data set, wide data, y being heights data, and we tell it which variable to merge by for each of these. So it's going to look for the ID variable from the wide data set. It's going to look for the ID variable from the heights data set. It's going to match up the IDs that are equal between the two, and then it's going to take the data from both of those and put them on the same line where the IDs are equal. Right? So if I highlight this or put my cursor on that line of syntax and run it, I now have a new data frame, all data, which I'll show you, where the beginning part of it is all the data from wide data, and the last column now is the height in inches for that respective ID. So that merged the two files together. Have you had to merge files in other programs before? Well, sort of a thing we may have to do. So I'm hoping. Okay. Another thing we have to do in this class occasionally is change the way our data is stored. Our data in wide data is what we call wide format. Meaning, for each observation, we may have, let's say in this case, we have four time points, let's say. This is like a repeated measures design. And we have 4 pieces of data for them. DV1, DV2, DV3, DV4. And at each time point, we also collected their age time 1, age time 2, age time 3, and age time 4. We can go, a lot of the packages that we use will not want data in this format. They may not want it in wide data format. They may want it in long data format, which means for each observation, each time point appears in the data file. So, question? So I created a function to try to make this process a little bit more simple. It's simple as in quotes, to transform it. What's that? Fun, yeah, haha. To put the fun in, I don't know, put the R in fun. No, none of that's not it. Funner, there you go. There's a package for you. The function, this is part of the EPSY 905R package. So when you do library EPSY 905, there's a function called multi-wide to long that will do this for you. And the way it works is the following. You give it a wide format data set. In this case, we're calling it all data. You tell it which ID variable you have in that data set. And you give it a list of variables that are in the wide format that now have to be in the long format. And so by list, what am I talking about? A list is another type of R object, which is somewhat painful. But the list itself, if you tell it, I'm going to create a list, and my first variable name I'm going to call DV, and it has, this is the dependent variable, it's at time 1, time 2, time 3, time 4. This C function right here puts all 4 of those into a single vector. And this creates it. So if you're creating this yourself, if you've got multiple time points, you just put the name of the variables at multiple time points in this C function. And you put the brand new name of the variable you want after the $ of this list that you create. And the same thing with age. There's shorthand ways of doing it. This paste function here works, by the way. I'm going a little bit quicker so I can get through the contents of this today. But you can go back to it online, and then there's also more help between now and whenever, particularly next week when we get to class. We've got time set aside to do this, okay? So we're going to get back to this. If you're feeling lost right now, hang in there. This is a little bit odder scenario because I didn't just hand this to you and say start. I wanted to give you a start in R person by person, or at least lead it. And that usually means it's hard to help idiosyncratically troubleshoot your issues, but we're going to get there. Hang in there with me. So this little paste function here just makes it shorter in code to do, but we're not going to worry about that too much. Again, you tell it the name of the new variable you want, and you put in there the 4 variable names as they currently appear in the data. To use this function, it creates an all-new data set that looks like the following. Here's IDs 1 through 10. At current time point 1, here's each of the dependent variables for each of those people, and the age. So if you want to compare and contrast the wide with the long, remember, at time point 1, the first person's value for DV was 21, the second was 21, the third was 20.5. You see 21, 21, and 20.5. So it's resorted the data. Now, why do you need to do this? Well, up until like week 6 of the class, you don't. But pretty soon, if you're going to do anything with a multivariate model using like a multi-level software package, this is preliminary how you need your data to work. It works very much in this long format. It's a programming convention that makes life a little bit more difficult, but there's we'll find ways to overcome it. If you'd like to do some descriptive statistics for your data, there's a great package I like called Psych. There's lots of ways, by the way, of doing descriptive statistics. One of those packages out there is called Psych. You can install the Psych package, all in lowercase. And it has a function called Describe. If you give it a data frame, it tells you a bunch of descriptive statistics about the data. So what you see here is, for each variable, the number of people, a number of observations in each, the mean, the standard deviation, the median, and so on. Probably more than you need to have. So we can give it the wide data set. We can give it the long data, or the long data set. See the same type of descriptives. The other thing we could do is descriptives by group, which sometimes you want to do. So this describe function describes all the data. We could describe it by group. So each person in our study had 4 observations. So we can go and get a person mean across each of the 4 time points. A person is our group in this case. So we use the describe by function. We tell it all data. And we give it the group being the variable ID for that. And sure enough, now we see for each person, for each group, 1 through 10, we see the mean DV, the mean age. What you should see is the mean time is the same because time is 1, 2, 3, 4 for each person. So it now drills in by group for the data itself. Sound at least a little interesting? There's numbers, statistics. We got some. It's not just playing with data and being frustrated. Hang in there, though. Again, if you're frustrated, hang in there. Yes?
When we run line 190 with the library site, were we supposed to be able to...
If you get an error with it, if it's red, you'll have to install the package. So you have to run this install packages site. I skipped over that because it takes a while for me to install it, and we're just a little short on time. I wanted to make it to the end of this file because we're about to have, I'm going to show you the homework that's basically repeat this with different data sets. That's where we're going. So Hang on one second here. We're going to finish up with transforming data. If you want to transform data, perhaps you want to go and mean center a variable. The way to create a new variable in a data frame is to put a dollar, take the name of the data frame, in that case, all data long, put the $sign, and put the name of your new variable. In my case, I'm calling it age C, standing for centered age. And what I end up doing is taking age and subtracting off the mean of age itself. So in this case, 11.1375. I could have done this, so that's how it works. The mean is embedded in this output here, but one easy way to do it, if you can just find the mean, 11.1375, you can just hard code that in if you wanted to instead. Should have made that a little bit easier. There are other ways to do it that are more complicated. I just put them in there for your reference. You don't have to do it that way. Just literally typing the mean of the variable in works for me to get you started, right? And instead of overwhelming with complicated, let's forget it. The last thing I'd like to show you is sometimes you need to round, particularly if you have time variables. You want to round time a little bit to nearest year or nearest decade. There's a function called signif, which means significant digits. Right? So if we look at our age variable, bless you. Our age variable appears to have in every tenth of a year, 8.7, 8.9, and so forth. We could round it to the nearest year by using 2 significant digits. So now that means right there. And we could round it to the nearest decade by using 1 significant digit. So I know we're sort of at a rush here, but I want to say one thing at the end, because our homework is on R. Our homework is on R. There's those of you who study linguistics, there's the our and R merger? I don't know, it's the thing. My our and R getting together. But our homework as a class is effectively that syntax. But instead of using heights, instead of using wide, we're going to use 2 different data sets, one called husbands and one called wives. It's data from husbands, data from wives. There's 4 time points. And you're going to have to import the files, merge them, create a long data frame by merging them, by transforming it, do descriptive statistics, and create new variables themselves. Now, if this overwhelms you, because right now you haven't gotten R to work, I can understand that. But let me tell you, this homework is due in 2 weeks, first of all. 2 weeks from now, you have to do this. Number 2, I'm putting this here to get that initial, oh my goodness, out for R. R is tough. It's a really tough user learning curve, right? So you don't see a lot of statistics in here because all I want you to learn is try to get your data in and to get it in the shape you need it to be to do most of the stuff we're going to do in class, right? So next week when we come to class, we will come back to the data and what you might have issues with the syntax and getting this running. And we can talk about homework in that open R session as well. That's totally cool. But the other thing I'd like you to do this week is to watch the 2 videos I just posted. One about descriptive statistics, get us to think about statistics again. One about regression and ANOVA put together. It's sort of an advanced look at linear models. And we'll also, when we come to class next week, have another R example to work with as well. But when you're watching these videos, once again, I will enable a thread on the forum that you can put your questions about the videos. So please use that to put questions and answers. If there's not a lot of questions and answers, we'll have a very short period for that. We'll have a long time to talk about R. And you'll get the individualized attention you need because there'll be 2 of us walking around this next time. I won't be lecturing. Okay? So hang in there. Aisha.
So for the homework, the husbands.sap, we have to have SBS in order.
Do we? I don't have it installed on mine.
I don't have it installed on mine, and I can't open it from the
I think we were not trying to read the SPSS, the ARB.
Ah, okay, so it might be did you load the foreign library? So if the error was cannot find read.spss, you have to put library foreign. I'll come show, come. So to make a long story short, I don't install SPSS because I want to be protected by anybody who asks me stat questions. And it works for me. I'll work with you to find out why it's not working. Okay, and I'll do the same here too. So just if you're welcome to come up after class, I'll be happy to show you. Thank you, everybody. I look forward to a great semester.